Now that we have our 6-pin header, we can simply make the same connections between components as we did between resistors and op amps. We just come along and choose this, and pin 1 is supposed to be connected up here to pin 1 actually on the PIC, so I can do that. And it should be that pin 4 is connected over to pin 4, actually coincidentally, up here. And pin 5 is connected up to pin 5. No particular reason why it happened that way, it just happened that way. And I've got the connection between these components that we've always had. The thing that I'm not crazy about when I'm looking at this is kind of messy on my schematic, that I've got these wires running from far away. If there's going to be other things on the schematic that want to be in this location, it kind of ties up space. And so if this is all I had on the page, there's nothing wrong with what I've just drawn. If we want to try to have a connection between two components that aren't right next to each other, then I want to see what my other options are for actually having the connection, so that when I go to do the PC board layout, it knows that this part is connected to there without tying up all the space on my schematic. My first option is to use these actual net names that we have not been paying really any attention to at all. Let me delete these lines between here and note that I've still got wires here, but there's no reason for Eagle to know that this wire has anything to do with that wire. But if I zoom in on this wire and I right click on it and look at the properties, I see that it's got this name N$7. It's called net7 for Eagle. What I'm going to choose to do, I know that input from the header is my master clear line. So I'm going to call that master clear. I can give it my own name. So at this point, Eagle knows that this wire is the N clear line, but no one reading my schematic can see that. So if I come down here to this icon that says place a label on a wire, if I select that and I click here, then that M clear line becomes something I can move around and I can place. So I'm going to go ahead and call this M clear. And because I don't really have any need for this wire to be that long, I'm just going to leave that there. The number 4 pin is actually called program data. So again, I'll use the information thing this time, and I'll say the information for this net. And instead, I'll call this net, I'll call it program data. And I'll decide that I want to be able to see that for this as well. And I know that this particular line is the program clock. And I'll also display that. At this point, I have these nets labeled, but there is still no idea that those points are supposed to be connected up to these points. So at this point, I come along, I go to the same place where I want to make a connection. There's no notion that this M clear wire that's coming off of here is supposed to be connected to the M clear wire that's coming off of the header. But what I can do is I can come and look at the name of this net, is another way to see this, and I can make this M clear, and it will say, do I want to connect what it was to M clear? I do. It happens to pop up the label right away for me already, so that's nice. I can do the same thing in the label here. I know that this is supposed to be program data. Yes, I do want to connect those, and yes, it wants that name on there. And do finally the same thing here, program clock. Yes, place the data. At this point now, and I might as well shrink this down, Eagle now does know that this M clear is the same thing as the M clear down here. Now knows that this M clear is connected to that M clear. This data is connected here. This is connected here. So from Eagle's point of view, it knows now that that connection has been made. And when we move over to doing the board layout, it will expect me to have an actual trace on the circuit board that connects those. If the board isn't too congested, this is not a bad way to connect things, but it does rely on me as someone who's trying to work with this to look and say, oh, I see that there's this M-Clear net that's coming into the, I wonder where it comes from. And I don't have a wire to follow to see, oh, I see it comes from that connector. I have to go and look and match up names. If that's a problem, then we're going to default to option number 3. Remember, option 1 is I run a wire. Option 2 is I just have these little stubs, but I give them the same name. Option 3 is to create a bus between 2 points. My last option is to include all 3 of these lines in a bus. A bus is the concept of having multiple wires that all in some way belong together. Because these are all 3 wires that pertain to programming, we could call it a programming bus. The 3 wires, it's not necessarily all that interesting. When you get to 8 or 16 wires and you're trying to run across a schematic like this, then it becomes a little bit more of something that's a benefit. But let's just see how to do it anyway. First thing is I come over here and I'm selecting blue, which is for a bus, as opposed to the wire, which is for an individual connection. So I select a bus and I just draw a line that is showing me where I'm going to be connecting all of the wires. It's a little bit like if I were trying to say, here's the channel all the wires are going to run through. So I have this bus. I come along and say, I want to look at the name for this bus. Comes up with the name, and I'm going to give it a new name. I'm going to call it my programming bus. But here's where it gets a little different. I put in a semicolon, and I include the names of the signals that I want to put in here. So I put in that I want to have a master clear. I also want to have a programming data, and I want to have a programming clock. All I see is the name programming bus. I don't see all the other options. Now I come along to make connections to this. I take pin 1, I connect into the bus, and it says, so which of these options is it? I say it's the master clear. I can put the name there. I come along to 4, and I say, let's connect this here. It says, which is that? Well, that's my programming data. Same thing with 5. I come across and I connect in, and I say that's my programming clock. Then I do the same thing up here. I've got my master clear. I put it in and say, yes, that's master clear. And I'll drop the name on there. I go to 4, connect up to my bus, say that's the data. Then I go to 5, connect in, say that's the clock. Anybody who's looking at this now and trying to find the connection can obviously see that these all kind of join together, run down this pipe, and then make the connection here. So the line shows me how to find my way from one to the next. And when they want to know the specific connections, I don't just have unknown wires disappearing in here and coming out as unknown wires. Someone can follow that the master clear comes here, goes through and makes the connection in like that.